We have a problem from the SMT of 2022. We want to compute what 5 plus the square root of 6 divided by the square root of 2 plus the square root of 3 plus 7 plus the square root of 12 divided by the square root of 3 plus the square root of 4. And you add all the values in between here, this and the last term, which is 63 plus the square root of 992 divided by the square root of 31 plus the square root of 32. We first see a pattern in each term here. On the bottom, in the numbers inside the square root, the second number is the first number plus 1. We also see that when you involve two terms, the second number in the term before is actually the first term. Well, the first term in the second term or the term after. And we also notice that in that the numbers inside the square root add up to the first number being added on the top, and you add what these two square roots multiply to. So, for example, the numbers inside the square root on the bottom, which is 2 and 3, 2 plus 3 is 5. Now you multiply these two terms to get the square root of 6, and that happens every single term being added here. So now we know that 31, so according to that, just rule of this problem, we know that 31 times 32 is 992. That will be an important piece of evidence later. Now, we also see a problem. All of these denominators on the bottom, they're all square roots being added. We want to get rid of them. So, we utilize the formula a plus b times a minus b. So, let's just start with this first one. 5 plus the square root of 6 divided by the square root of 2 plus the square root of 3. This is equal to the 5 plus the square root of 6 times the square root of 2 minus 3. No, the square root of 3, because you want an a minus b here. So you're dividing it by the square root of 2 plus the square root of 3 times square root of 2 minus the square root of 3. You do that, so these cancel out and it's still the same value. Now we just keep on simplifying it until we get two terms being added or subtracted. So when you do this on the bottom, this is just 2 minus 3, since it's squared and there's no more square root. 2 minus 3 is negative 1. So this term is now, this top, I'll just write it out. So it's going to be 5 times the square root of 2 minus 5 times the square root of 3. That might not look so good. Plus the square root of 12 minus the square root of 18 divided by, this is just negative 1, as I stated earlier. Now we can actually take out some numbers inside these two square roots to get only two terms, and then we can just put the negative 1 in. This is 5 times the square root of 2. Let's see, we can use this square root of 18. 18 is 9 times 2. 9 is 3 squared. So when you take out the 3 squared, it just becomes a 3. And what's left is square root of 2. So now we do that with these two terms. So minus 5 times the square root of 3 plus 12 can take out a 4, which is 2 squared. So let's do that. So it becomes 2, and what's left in the inside is the square root of 3. And this is all still being divided by negative 1. Now we can just like solve. This right here is 2 times the square root of 2 minus, wait, no. This should be minus here. No, it is plus. I'm sorry, it got mixed up, but this is essentially 3 times the square root of 3 divided by negative 1. Now we put the negative 1 inside. This is effectively, now switches around, 3 times the square root of 3 minus 2 times the square root of 2. Here, right here. So we have our first equation right there. So we use the strategy we used to solve the first term to solve for the second term. So this second term is 4 times the square root of 4 minus 3 times the square root of 3. Now, from these two terms, we can actually prove a pattern. So we see that these numbers, this is 3 and 2, but in the original bottom, it's 2 and 3. That's the order. So basically, it's just what the rule is you flip it over and then take the number in the square root out and subtract the other term. It works as well here. So this term, now that we have stated that rule, this term is now equal to 32, since it's reversing, times the square root of 32 minus 31 times the square root of 31. So now we can just plug these values into the original equation and see what happens. So our first term is 3 times the square root of 3 minus 2 times the square root of 2. And now you add 4 times the square root of 4 minus 3 times the square root of 3. And now you add all of the values in between according to this rule until the final term, which is now 32 times the square root of 32 minus 31 times the square root of 31. I feel like that's too much dots, but you get the idea. Now, you actually see something pretty weird happen. These cancel out, and on the next term, this 4 will cancel out all the way. So the only terms without that cannot be canceled out is the least term, is the least possible term here and the greatest term here. So what you're really left with here in the original equation, all we have to do is compute what 32 times the square root of 32 minus 2 times the square root of 2 is. Now, we know that by factoring, we can just make this 128 times the square root of 2. That's what it is when you take out the 16 factor minus 2 times the square root of 2. So our final answer is 126 times the square root of 2. So we have computed that.